Hello everyone, this time we're in example 10-6. So, let's read it out. So it says, calculate the required diameter of a 3-meter long steel rod subjected to an axial tensile load of 67 kilonewtons. The yield stress is 345 megapascals. Use a factor of safety of 2.5 based on the yield stress. Okay, so given length is equal to 3 meters, the tensile load is going to be equal to 67 kilonewtons. Yield stress is equal to 345 megapascals. And the factor of safety needs to be 2.5 based on the yield stress. And so it's telling us to solve for the allowable stress. And then just using that to calculate the diameter. So find diameter. What is it? What is it? Okay, well, the first thing we're going to do is actually write our allowable stress. What is the allowable stress? So we're going to use that factor of safety equation to figure it out. So factor of safety is what we care about, which is the yield stress, over our allowable stress. So I'll go ahead and solve for this guy. And then I can start plugging in numbers. So it'll come out to be 345 megapascals all over 2.5, which means my allowable stress is 138 megapascals. Okay. Now I'm not done there. Now I need to calculate what the diameter of this rod would need to be. So with that, I can go down to my regular stress equation. So stress is equal to the load over the area. And we know that if we know the area of the rod, since it's circular in cross-section, we can calculate the diameter. So before I go any further, I'm going to solve for the area. So area is equal to the load over the stress. That's going to be equal to 67,000 newtons over 138 megapascals. And remember, I'm using this, keeping it megapascals, because 1 megapascal is equal to 1 newton per millimeter squared. And that makes things easier on me. So the area would then come out to be 486 millimeters squared. Then if you look in the front of your book, you can see that the area of a circle is pi over 4 times the diameter squared. And I want the diameter, so let's go ahead and solve for that. So d squared is going to be equal to 4a over pi. And I take the square root, and so d would be equal to square root of 4a over pi. Okay. And if I plug all my numbers in and I do it correctly, I should get 24.9 millimeters as the allowable diameter to make sure that everything passes. And then I'll be done. So in this problem, what we did was we used our factor of safety equation to determine an allowable stress. We then used that stress to determine the area of our cross-section of our rod. And since that rod is circular, we could calculate the diameter using our area of a circle equation. I hope this made sense. If you have any questions, please feel free to post them in the forum, and I'll see you in the next example. Have a good day.